Alright guys, we're on solutions here, and I already talked to you a little bit about molarity, but I just want to recap it so you have this video. I will also be talking about molality in this video, but in this way you can pause, rewind, and cover concepts. Biggest thing to know for going forward, working out these equations, is definitely know the difference between a solute and a solvent. The solute is what is dissolving. The solvent is what does the dissolving. So water is a solvent. Uh, like sugar would be a solute. It dissolves. There's three ways to measure, or three units to three measurements of concentration, which is molarity, molality, and mole fractions. I'll cover the first two in this video. But basically, what is determined upon concentration is the amount of solute in a given solution. Um, so if you have tons of sugar, which is a solute, in a liter of water, then that's high concentration. If you have low amounts of solute of sugar in that 1 liter of water, then it'd be diluted down, low concentration. Same concept here, but we're working with other things besides sugar and other solutions besides water. Water is the most common though, and so we will be using that a lot. So here we go. Molarity is abbreviated capital M. That's unit, capital M. We're dealing with moles here. So remember, always convert to moles. Um, so here we go. Here's the equation. Definitely memorize this equation. Memorize all these. You memorize the three equations I give to you, but this is super important moving forward. Just take the time to memorize it. So capital M, molarity equals moles of solute over liters of solution. So recognize moles of solute. Usually in these problems, you'll be given grams of the substance. So if you're dealing with sugar, 10 grams of sugar, that's usually a common unit for it. You just always have to make sure you convert it to moles to be able for these equations to work to get to molarity. And notice that the denominator here is liters of solution. Sometimes you'll see milliliters in your practice problem. You just have to convert that to liters. Just move your decimal point over one to the left. So here we go. Vinegar is a solution of acetic acid. What is the molarity of the solution produced when 125 grams of acetic acid, which is C2H4O2, is dissolved in sufficient water to prepare 1.50 liters of solution? So here we go. You take what you're given here. So you're given 125 grams of C2H4 or H4O2, and you're given 1.50 liters of solution. This is in liters, so you know you don't have to really do anything. No conversions here. But here's your solute in grams. We know we need it in moles, so what's our first step? Convert it to moles. The way you do this is find the molar mass. Remember stoichiometry, remember all the chapters before this. Convert to moles, you have to add everything up. So you have C2H4O2. Carbon, if you look at the periodic table, is 12 AMUs. Convert that to grams. You have two of those. So here we go. You have 4 hydrogens, each weighing 1 AMU, which is 1 gram. So you have 4. And then you have 2 oxygens, each weighing 16 AMUs, 16 grams, times 2. You add them up and you get 60 grams per mole. That's the molar mass of acetic acid, 60 grams per mole. And we're going to use this for our equation. So let's write out our equation. So we know how to solve for M. Moles of solute over liters of solute. Obviously, we don't have moles yet. First step, you just write what you have, okay? Write what you have. So we have 125 grams C2H4O2 over 1.50 liters of solution. That's what we have. That's grams over liters. We need moles over liters, so here we go. Let's get rid of grams. Let's convert it to moles. Always remember. So grams to moles. 60 grams per mole. Multiply the top, multiply the bottom, divide it. 125 divided by 1.50 over 60, which is 90 or something like that. I think it's 90. You divide that out, 125 divided by your 60 times 1.50, and you should get 1.39 moles, and you can write it like this, capital M. 1.39, capital M. And scientists can look at that and know the concentration. That's solutes per liter of solution. There we go. Get pause, rewind if you need to. Let's start talking about molality. Here we go, molality. So in molarity, it was moles of solute per liters of solution, the solution that everything when mixed together. So if you have 1.50 liters of a solution, then that's what you're dividing everything by. Here in molarity, or molality, the abbreviation is little m. And to solve for little m, it's moles of solute, so the thing that dissolves, over kilogram of solvent, the amount of the substance that does the dissolving. So memorize that. Moles of solute, so little m equals moles of solute over kilograms of solute. Okay, memorize it. So here we go. Here's an example. So chlorine is often used to treat water in swimming pools and drinking water to keep water clear and free of living organisms. So that's a common thing. Chlorine, too much chlorine, high concentrations, it's toxic, it's poisonous. So this should be low amounts of chlorine in the water and in swimming pools. So here's your problem. What is the molality of a solution made up of 16.1 grams of chlorine? And chlorine's a diatomic molecule like oxygen, nitrogen, so O2N2, chlorine is Cl2. There's two chlorines combined. It's a diatomic molecule, so Cl2. In 5,000 grams of H2O, so in water. So they're adding 16.1 grams of chlorine per little tablet into 5,000 grams of water. So first off, there's some conversions need to be done because grams is not moles, grams is not moles and grams is not the gram. So H2O is your solvent. Water is what dissolves. That's a universal solvent. H2O is always going to be your solvent. So that's not kilograms, that needs to be kilograms, and that's not moles, that needs to be moles. So that's our first step. So this is our solute, and this is our solvent. We need this to moles. So we have 16.1 grams of Cl2. We know, diagonal it out to get to moles. So how do we get to moles? We'll look on your periodic table and figure out how much one chlorine weighs. One chlorine weighs 35.45 AMUs, atomic mass units. Convert that to grams. Multiply that by 2, since there's 2 of them, and you get 70.9 grams per mole. So 70.9 grams per mole. And then what do? Multiply the top divided by the bottom. And you should get 0.23 moles. So now we have moles. So we can plug that in. M equals 0.23 moles Cl2 because that's your solute. And now we need kilograms of solvent. So we have 5,000 grams, kilograms. It's 1,000 per. So all you have to do to convert grams to kilograms is divide it by 1,000. 1,000 kilograms per gram. So 5,000 divided by 1,000 equals 5. You have 5 kilograms of H2O. So now we have moles of solute, kilograms of solvent. Now all you have to do is divide the top by the bottom, and you should get 0.045 molality, little m. 0.045 moles molality. And that's always going to be moles of solute per kilogram of solvent to understand the concentration here. Um, so that's a low number. That's good. You don't want crazy high numbers for chlorine when you're drinking it. So that's a good thing. So remember, always convert your units to kilograms and moles. For molality. Molarity, always convert to moles. Make sure it's in liters of solution. So if it's milliliters, convert that to liters. You can do simple moving the decimal point over, or convert it online if you need to. But kilograms and kilograms, all you have to do is divide it by 1,000. So that's molarity and molality. That's your those are two common units of measurement for concentration. Um, the next video you'll see is on mole fractions. Then we'll progress along, and then that covers once I cover mole fractions, that'll be done with the equations. I'll sign a worksheet, and but I think you guys won't have any problems for this chapter. Have a good one.